Okay, hello everybody. My name is Greg Demchak. I'm going to be talking today a bit about new methods of human-computer interaction with digital twins, with 3D models, with photogrammetry, and I'll just jump right into it. I think it's interesting too, the speakers actually that were here this morning, I could actually plot them on this timeline. I met Greg Schleusner actually when I was working at Revit and interviewing him as an early adopter of Revit technology. I was a UX designer for that platform for many years. And Cobus actually met when we were developing adaptive components here in London, adding that feature to the family editor. And Marzia actually met in Boston. They were early adopters of Synchro for the renovation of Boston Logan Airport. So my history is basically that, a series of product developments, starting with BIM, then getting to 4D construction simulation. And now within Bentley Systems, I'm looking at a new category, which is the digital twin with XR, which is new methods of human-computer interaction. And actually now with Metaverse, with David, I'm now working with him. We actually executed on a Epic mega grant this year and can now get all of this content into the Unreal game engine. So just interesting overlap. Bentley Systems, if people don't know, we're a global software provider. Really, there's a focus at Bentley on core infrastructure assets. So anything from train stations, rails, roads, tunnels is a sort of core focus of Bentley Systems. Obviously, architecture's in the mix there as well. And the focus largely for Bentley has been on developing products that then get shipped into the market. And I'm going to talk a little bit about a shift in thinking from product to platform. And I think it's similar to what Epic was sort of presenting, that really a digital twin is not going to be a single product you buy off the shelf, like Revit or MicroStation or Synchro. It's just too complicated for that. It's going to have to enable interaction with a lot of different systems. And so Bentley, we've actually shifted from, well, there's still all the products are for sale, but it's more developing a platform that would allow you to import a wide range of 3D content and a wide range of reality-based content into a platform and essentially build whatever you think is appropriate. It's a big ask. But it's interesting, you see this work here, this is a roadmap to 2030 that's been put out here in the UK. And there's this idea of like societal impact, sustainable development goals, reaching all the way down to natural built environment and operators. It's very subtle, very silently in the back there, you see this sort of ring of digital twin there. So there's definitely awareness at the government level that the digital twin is going to play a role in solving this problem. And digital twin is not a product, I would say. It's a bit like BIM. There's no single product that solves that. Our current approach is to really start to think about input outputs. So primarily you've got digital reality in various different formats, point clouds, laser scans, 360 cameras, et cetera, photogrammetry, and then you've got design models coming into this system, merging together in a cloud format, so cloud storage, revision management, and then from that you can egress to a wide range of applications and user experiences, whether that be a desktop, web, I'll show an example of HoloLens or VR. And I think this is eventually where you're going to see the metaverse emerge. It won't be a single provider. It's going to be a wide range of user experiences on a wide range of devices and interfaces. There's just an example of what that looks like practically speaking. This is Photogrammetry Capture here, University of Cambridge, one of the first prototypes that Bentley built of a digital twin, really talking about this idea of going from scale of the globe to a region, to a city, to a building, into a room, and then up to an actual pump. And at the pump, you can actually then start to interact with IoT data, sensor data. So not just a photogrammetry mesh, which is really inherently not intelligent, but how do you start to give intelligence to this reality capture and merge information with reality capture? So that's what you're sort of seeing there. Other examples of this, if we start tracking and recording the motion of people, they can also be represented, re-rendered back in a 3D scene. So the way people interact with an asset can now be modeled and rendered and played back inside of these digital twins. This is our recent example. of an egress out of the platform into Epic, into Unreal Game Engine. This is a Synchro model that got, the 4D sequence was created inside of Synchro. Here's the interface for that. This is literally just the linking of the construction Gantt chart schedule with BIM elements. So the animation is a function of rendering the construction schedule. And then it comes out of this iTwin platform, that's the Bentley platform, digital twin platform, comes into Unreal Game Engine. And then once you're in Unreal, really the sky's the limit. You could build a video, an animation, load new content, produce custom timeline sliders like that. So the idea there is that like Synchro, it's a product that you author it, but you might want to then tell that story with other tools in the market. We've also started looking at how to get content into the Omniverse, which is another, we saw that presented this morning. So that's that same model, it's a microstation model pulled through USD into the Omniverse to get that next level of visual fidelity. So from our perspective, whether the data goes to Unreal, to Unity, to Omniverse, it doesn't really matter to us. We're making it possible for that content to egress to whatever platform makes sense, rather than try and sort of hold the data in or solve this problem inside of a single desktop application. Now I'm going to jump to human-computer interaction. I don't know if this video is going to play. I'll skip this in a minute. This is Doug Engelbart. Is everyone familiar with Doug Engelbart? Who's watched the mother of all demos before? A few. Okay, I have this video here. I would encourage you all, when you go back to YouTube, just check it out. Here's the inventor of the mouse. And he first gave a live demo of the mouse back in 1968. He also demonstrated live video teleconferencing. He piped someone in and had a live teleconference and did co-editing, co-authoring of a Word document, not Word, a text document on the screen live. What led him, though, is interesting. Since an architecture community, I threw this in here. What led him to invent the mouse, at the time there was the light pen that was developed by Sutherland. He had this imagination, this is 1962, that the architect would be working on a 3-foot by 3-foot screen with input on the left and taking measurements on the right. And he'd be able to conjure from the computer, I think he calls it the Clerk. I think this is really maybe the first instance of imagining an AI assistant helping you generate. He imagines that this Clerk produces a perspective rendering of his imagination. And I think his one point of missing is he somehow overlooked that he could integrate annotations, back to Greg Slusher maybe, that you could actually integrate annotations into the 3D model. He actually dedicated 1/3 of the screen for just a readout of dimensions. But anyway, all these things were demonstrated, shown all the way back in 1968. So I'll jump quickly here. So the progression is quite clean here. We've gotten quite used to using keyboards and mice and screens as our primary way of inputting data. With the Xbox, also hand information. We do get some vibration feedback there, but they also added the Kinect motion sensor, which could detect body motion, and then you could play with the game. That technology has now been embedded inside the Microsoft HoloLens. So I actually canceled Xbox Kinect controller, and I'll just show you some videos of what that looks like. And so now the human-computer interaction, because the sensing is now on the device, can pick up natural gestures. This has now been added to the Oculus as well. I think Vario is downstairs. But what you're seeing is a shift from the human having to type or use a mouse as the mediation to like literally just your hands. Hands, voice, head. Wherever you look, that's where the gaze directs you. The top are all apps that we've developed. There's also the ability now to bring in avatars into the scene with you. These are 4 examples of prototypes we've developed on top of this technology. The key to the breakthrough here is that we started using Azure Remote Rendering, which is a remote rendering service. So in this case, we are no longer loading any geometry onto the local device. It's all being streamed, and what that meant, and this is the theme I think I've heard all morning, there's no practical limit to the geometry size. You can stream unlimited scale polygons. You don't have to decimate or go through this kind of washing in order to get that experience into a head-mounted display. And so last year I did some rapid prototyping. I sort of shifted gears from my architecture, construction focus, and looked at this one use case, which was a bridge inspection scenario. And what would it take to sort of introduce this technology into this type of persona? This is an inspector. This is what they typically do. They're trained to do this kind of work. This is actually GoPro footage camera from one of the clients that I worked with. This is they are harnessed in, they're certified, and they descend down the sides of these bridges to do an inspection. So we said, what if we take the drone out there, do the capture of the bridge, make a photogrammetry mesh, so a reality capture of that mesh, and can we deliver that same type of experience to an inspector inside a web browser, but then going beyond the browser into an immersive head-mounted display. So here you see, this is the AI piece, by the way, I'll make it quick. This is generated machine learning detecting cracks on the images and then re-rendering that content back into the photogrammetry mesh. There's a lot of opportunities for machine learning here because it's all based on photos. So you can train the photos can be marked up by machine learning and then delivered into the experience. And this is what it looks like. It's hard to maybe capture here. This is a capture through my HoloLens and being immersed in the office inside of the bridge at 1-to-1 scale. So you can now get into these assets at high resolution. There's no loss of fidelity here. It's millions of polygons being rendered 60 frames a second over Wi-Fi into the device. And the only thing you need to learn how to do is just move your hand in space and you sort of guide yourself through the model. So the goal here was to try and get a bridge inspector to have an experience that is as simple, as easy and intuitive to use as possible. And you sort of get a sense of the resolution of that mesh. This applies for any mesh that can be captured in reality. So if you think about that's for a bridge, and you imagine the number of environments that you could capture with photogrammetry and that you could go to experience, that really, for me, starts to plant the seed for what would be a metaverse experience. And so, I want to see if I can play this video. This is recorded just yesterday with my colleague Sasha. She's here with me today. This is now using a new tech Microsoft's developed called Microsoft Mesh, which was announced by Microsoft recently, after the whole Facebook rebrand to Meta. Microsoft's also in the space, and we're exploring this as well. Here I got myself and Sasha in 2 separate rooms, working on a shared asset, having a conversation, dropping pins, drawing, and even talking and having subtitled text appear in real time. So we can now start to work and collaborate from a distance with 3-dimensional space, mixed reality, and have an avatar experience. I'll tell you, it's quite interesting. The avatar, it does start to get agency. Like when I'm talking to Sasha, I see her head motions because the HoloLens is picking up the gestures of hand, head, and even with eye tracking, it picks up when you blink. So all the gestures are kind of coming through, and you actually start to have this sense that, okay, my colleague is actually right there in the room with me. And so there you can see, she see me look at the bridge, and then I'll show you, this is what it looks like a little bit behind the scenes. If I'm in the same room with her, you kind of see what's happening here. My avatar is being generated in real time by the HoloLens and projected into my space. And so every gesture I make is written in real time into this digital twin of myself that people can interact with. So just a couple more examples of just the quality of this. So again, the interaction's all just hand gesture. A couple use cases I've been imagining, if you were to scan even say this room or any room that you have inhabited, with this type of technology, we could have a conference like this, we could all teleport into it and would have photorealistic experience, and we could actually interact with each other. There could be people sitting in the room together, interacting from practically anywhere. And this is sort of this last moment here. This is what we're used to, is we can see a 3D model on a screen. We can project that onto a screen like I'm doing now, but we can also now bring that 3D asset physically into the space with you. And so you can kind of work across all dimensions there. But it's really quite interesting to go from an interaction on a screen and like literally have the 3D model be something you can reach out and practically touch. And I think I'm running short on time, but this is just an example video that we produced with Collins Engineering. I think what was interesting here is the client had come from having never experienced a HoloLens or a mixed reality device before in their life. And Once we got them into the device, they started using it, they started to now actually buy the device, test it, and use it. So they're in active development and prototype with us. And that's it. So I know I want to make this quick because I know we're short on time today. Absolutely, if anyone wants to connect with me on LinkedIn, that's my QR code. You can write me on email or connect with me downstairs. I did bring 2 HoloLens with me. And if we get the chance downstairs, I'd be more than happy to fire up the laptop and maybe someone could have an experience of one of these bridges in the HoloLens. We don't have a booth, but we can show up and pop on some devices. So thank you so much. If you want to get into development, we also have the active development program, open source. You can go build all these tools if you want with Unity, Unreal, Omniverse, etc. So thank you.